Okay, in today's lesson, we want to be able to solve two-step inequalities. All right. Now, in order to solve inequalities, we use those same properties of inequality that we've been using for one-step inequalities, which essentially say whatever you do to one side of an inequality, we have to do on the other side. Here's our first example. It says 5 times a number, take away 4, is greater than or equal to 11. We want to use the same approach that we use when we solve equations. What operations do you see? Well, here I see subtraction, so I'm going to do the inverse. So I'm going to add 4 to both sides of the inequality. On the left side of the inequality, we're going to get 0. Right, and remember, the goal is to get the variable by itself. So in order to get the variable by itself, we had to remove this 4, and we're just using the inverse operation. Right, but on the right side of the inequality, we're going to be left with 15. So let's recopy now. We have 5 times a number is greater than or equal to 11 plus 4 is 15. Next step, we're going to divide both sides of the inequality by whatever is multiplying the variable. Here we have 5 as the coefficient of x. So we divide both sides by 5, and we wind up with x is going to be greater than or equal to 15 divided by 5 is 3. All right. So there's my solution. When we go to graph it, I always like to locate 0 on the number line. 3 is to the right of 0. I'm going to circle and fill in the circle, and my solutions are going to go to the right. Now I'm going to check my solution with a value that's in there. So let me try a value like 5, because 5 seems to be in my solution set. So if I replace x with 5, I would get 5 times 5 is 25. 25 minus 4 is 21. Is 21 greater than or equal to 11? Yes, it is. So I feel pretty good about that first problem. But let's take a look at our second problem. A little bit different. I see addition and I see division. So I'm going to use the inverse of those two operations to find a solution. First step, subtract 4 from both sides of the inequality. On the left side, that's going to be 0. So I'm left with a number b divided by negative 3, and that's going to be less than 13 minus 4 is 9. Now here we want to see that the variable is being divided by negative 3, so the inverse would be to multiply both sides of the inequality by negative 3. Right? And we have to remember that when we multiply or divide both sides of an inequality by a negative number, we have to reverse the inequality symbol to keep it true. Well, on the left side of the inequality, negative 3 in the numerator is going to cancel negative 3 in the denominator, so I'm left with b. But remember, we have to reverse that inequality, so the less than has to become greater than. 9 times negative 3 is going to be negative 27. So our solution is b has to be greater than negative 27. I want to check that solution, right? So let's go to our graph. I want to graph the solution, right? Here's 0, and here's negative 27 is going to be to the left of 0. All right, it's going to be an open circle at negative 27. My solutions are going to go to the left. So I want to check something in my solution set, see if it really is going to make it true. And I see that 0's in my solution set, so let's try that. All right. So if I replace 0 with my solution set, right, I divide. I say, okay, 0 divided by negative 3 is negative 3. I'm sorry, 0 divided by negative 3 is 0. 0 plus 4 is 4. Is 4 less than 13? Yes, it is. 4 is less than 13, so I feel pretty good about my solutions here. All right? Let's try the next page. It asks us to solve the following inequality and graph the solution. Now, these are always a little tricky because I see this subtraction, and very often students want to add to both sides of the inequality. But the goal is to get the variable by itself, and that 7 is a positive 7. And if I want to make that a 0, my first step has to be to subtract 7 from both sides of the inequality. That's going to be 0. Right? Now we have negative 2x, right, is going to be greater than 11 take away 7 is 4. Right? I see that negative coefficient. I want to get x by itself, so we're going to have to divide both sides of that inequality by -2. On the left side of the inequality, they're going to cancel, so we're left with x, but because I divided both sides of the inequality by a negative number, we have to reverse the inequality symbol, and 4 divided by -2 is going to be -2. So here's my solution. X has to be less than -2. We go to our graph. I have 0. We said -2. Let's go to our graph. Here's 0. -2 is to the left of 0. It's going to be an open circle at -2. My solutions go to the left. So I'm going to try something in my solution set, see if it works. So something less than -2, I'm going to try -3. If I replace 2 with -3, let's see what happens. I get 7 minus 2 times -3. Well, 2 times -3 is -6. Well, what's 7 minus -6? Well, when we add the opposite, that becomes 7 plus 6, which is 13. Is 13 greater than 11? Yes, it is. So here's my solution, and there's the graph of my solution. But you want to check those solutions to make sure that your inequality makes sense. Okay? Our next example, I have a number divided by 2 is take away 5 is going to be less than -8. I see subtraction, I see division, so I know I'm going to use the inverse of those operations to find the solution set. The inverse of subtraction is addition, so I want to add 5 to both sides of the inequality in my first step. They're going to cancel, so I'm left with a number divided by 2 is going to be less than -3. Now here's a common mistake for students, right? We see division, but the variable is being divided by +2. So to get x by itself, we have to multiply both sides by 2. We're multiplying both sides of that inequality by a positive number, so we don't have to reverse the inequality here. 2 in the numerator is going to cancel 2 in the denominator, and we're left with x has to be less than -3 times 2 is going to be -6. Let's check our solution set. I go to my graph. I have 0. I have -6, which is to the left of 0. Open circle at -6. Right, we're going to the left. Let's check something that's less than -6, so let's try -8. Right, -8 is in our solution set. -8 divided by 2, that's going to be -4. -4 minus 5 is -9. Is -9 less than -8? Yes, it is. All right, so those are typical two-step inequalities. Right, so here's 3 that you can kind of try on your own. Right, see how you do with each one of these. You're asked to solve the inequality and graph the solution. All right, so we're going to be adding 7 to both sides of this inequality using the inverse operations. On the left side, they're going to cancel. That's going to be 0. 6 times the number y is less than 5 and 7 is 12. Divide by 6, divide by 6. They cancel. Y is going to be greater than 12 divided by 6 is 2. I'm graphing that solution. I have 0. +2 is to the right of 0. It's an open circle at 2, and my arrow is going to the right. Quick check. I'm going to try something in my solution set. Let's try 10. 10 is to the right of 2. 6 times 10 is 60. 60 minus 7 is 53. Is 53 less than 5? Yes, it is. Next example. It's one of those problems where students make mistakes. They see subtraction, so they want to add 4 to both sides, and that would be a no-no. Because if I add 4 here, 4 plus 4 is not 0. We want to zero this out. I want to get the variable by itself, so I want to subtract 4 from both sides of that inequality first. It's going to be 0. Next place, student's going to make mistakes. That -3 coefficient, you have to bring that down. -3 times the number d is less than or equal to 19 minus 4 is 15. So at this step where we see the negative coefficient, we want to divide both sides of the inequality by that negative coefficient, -3. They cancel. D has to be now less than or equal to, we have to reverse the inequality because we divided both sides of the inequality by -3. 15 divided by -3 is going to be -5. So here's my solution. D has to be less than or equal to -5. Let's check it. So first I go to my graph. Here's 0. Negative 5 is to the right of 0. Closed circle, and your solutions go to the left. All right, so let's check something in the solution set. Let's try, I don't know, negative 10. 3 times negative 10 is negative 30. 4 minus negative 30 is going to be 4 plus 30. That's 34, greater than or equal to 19. That's going to work. Okay? Next example. I see the subtraction, or I'm sorry, I see the addition. So I'm going to subtract 8 from both sides of the inequality. On the left, that's going to be 0. We're left with W divided by negative 4. It's going to be greater than 9. Take away 8 is 1. I see that my variable is being divided by negative 4. To use the inverse operation, we'd have to multiply both sides of that inequality by negative 4. On the left side, negative 4 in the numerator is going to cancel negative 4 in the denominator. We're going to be left with W. But because I multiply both sides of the inequality by a negative number, we have to reverse the inequality symbol. 1 times negative 4 is going to be negative 4. I go to my graph. Here's 0. Negative 4 is to the right of 0. It's going to be an open circle at negative 4, and we're going to the left. I want to check something that's less than negative 4, but maybe divisible by negative 4. So I'm going to go with negative 8. Negative 8 divided by negative 4 is positive 2. Is 2 plus 8, which is 10, is 10 greater than 9? Yes, it is. So I feel pretty good about those solutions. All right? If we're given a problem like this example here, where we have to choose the graph, a couple of different ways you could do it. Right? First, you could check solutions or solution sets, but some of these look, pretty similar. The best thing to do is probably just to find the solution set on your own and then match it up with one of the graphs. So I see the distributive property. I'm going to do that first. Negative 7 times x is going to be negative 7x. Negative 7 times positive 3, that's going to be negative 21. Right? That's less than or equal to 28. Next step, get the variable by itself. We're going to add 21 to both sides of the inequality. That's 0. Negative 7 times x, less than or equal to, what's that, 9 and 4? That's 49. Next step, divide both sides by negative 7. On the left, they cancel. So we're left with x has to be greater than or equal to. 49 divided by negative 7 is negative 7. Notice we reversed the inequality because we divided both sides by negative 7. So x has to be greater than or equal to negative 7. Well, where do I see x being greater than or equal to negative 7? It's going to be answer B, right? Because greater than or equal to negative 7 should be filled in, not open, but they're all filled in. But it should be to the right of negative 7 on our number line, and that's what we see with example B. All right? Okay, let's see. I'm going to, let's see, do I want to skip that? No, let's do this one. A contestant in a weight loss competition wants to lose an average of at least 8 pounds per month during a 5-month period. How many pounds must the contestant lose in the 5th month to meet the goal? Well, so far they've lost what? 12 plus 9 plus 5 plus 8. And I'm just getting those numbers from this table here. Plus some number. I'm going to use a variable. When we divide that by 5, right, because we want the average, at least would have to be greater than or equal to, and then 8. So there's our first step, to actually write out the inequality. Then let's simplify by combining our like terms. 12 and 9 is 21. 21 and 5 is 26. 26 and 8 should be 34. So we have 34 plus a number divided by 5 greater than or equal to 8. Next step, get rid of that 5 using the inverse operation. So we're going to multiply by 5 on both sides of that inequality. On the left side of the inequality, 5 in the numerators, going to cancel 5 in the denominator. So we're left with what? 34 plus n has to be greater than or equal to 8 times 5 is 40. To solve for n, we're going to subtract 34 from both sides here. That's going to be 0. So now I'm left with n has to be greater than or equal to 6. And those are pounds. Alright? Okay. Let's see. Any of these I think we'd have trouble with? Probably not. But we'll go through them using the distributive property. Alright? So if we're using the distributive property, alright, let's do that here. Need a little bit more space. Good. Okay. First, problem 4, we'll distribute. So for problem 4, we wind up with 2 times k is 2k minus 2 times 5 is 10 is less than 6. Next step is to add 10 to both sides of the inequality. That's 0. 2 times the number k is less than 16. Divide by 2, divide by 2. They cancel. K has to be less than 16 divided by 2. That's going to be 8. Problem 5. Going to have to distribute. Alright? So for problem 5, negative 4 times n is negative 4n. Negative times negative is positive. 4 times 10 is 40. I want to write that as plus 40. Less than 32. Alright, 2 steps. Subtract 40 from both sides of the inequality. That's 0. Negative 4 times n is going to be less than, what's that, negative 8. Then we divide both sides by negative 4. On the left, they cancel. N has to be greater than, negative divided by negative is positive. 8 divided by 4 is 2. We reverse the inequality symbol there because we divided both sides by a negative number. Alright? Problem 6. We have negative 3. Oh, that's right. Oops. Let's do problem 6 here. Problem 6. This is going to be negative 3 is less than or equal to 5 tenths times 8. Well, half of 8 is 4. 5 tenths times y. That's going to be 5 tenths y. I want to get y by itself, so we're going to subtract 4 from both sides of the inequality. On the left side, negative 3 and negative 4, that's negative 7. Less than or equal to, that's 0. So we still have 5 tenths y. To get y by itself, we're going to have to divide by 5 tenths on both sides of that inequality. We're dividing by a positive number, so we don't have to flip the inequality symbol. What's negative 7 divided by 5? That's going to be negative 14 is less than or equal to y. This is a reversed inequality. Right? I forgot to graph the last one. A reversed inequality. It's the first one we've had during the lesson. We're going to have 0. Negative 14 is to the left of 0. When we have the reversed inequality, the variable's on the right side of the equal sign. What that means is that when we go to our graph, the solutions are going to be in the opposite direction of the inequality symbol. We have to fill in, right, a closed circle because it's less than or equal to. If we're not sure, I'm going to check, right, to be sure. So I'm going to replace with 0 because that seems to be in our solution set. 8 plus 0 is 8. Half of 8 is 4. Is negative 3 less than or equal to 4? Yes, it is. Alright. Now let's see. We have these couple of problems. I'm going to skip that. I want to go to some of the more crazier problems here. These are a little bit different. It says to solve each inequality with parentheses using the 4 operations, then graph those solution sets on a number line. Let's take a look at this first one. We distribute the 3. 3 times 2 is 6. 3 times x is 3x. That's less than negative 15. Subtract 6 from both sides of the inequality. That's 0. We're left with negative 3 times x is less than negative 21. Divide by negative 3. Alright, where did I get negative 3x from? Nope. Be careful there, right, because that's positive 3x. Right, so I'm not dividing by negative 3. Boop. right? So I'm dividing by 3 on both sides of that inequality, divide by 3, and we have x has to be less than negative 7, right? Now I'm not sure about that, so let's check it. So I'm going to replace a value that's less than negative 7. I'm going to try negative 10. 2 plus negative 10 is negative 8. 3 times negative 8 is negative 24. Is negative 24 less than negative 15? Yes, it is. So I feel pretty good about that. It does ask us to graph the solution on a number line. So here's my number line. Here's 0. Negative 7 is to the right of 0. It's an open circle. Arrow's going to go to the right. All right. Next example. Distribute. 1/3 times 2. It's going to be 2/3 minus 1/3 x. It's going to be less than or equal to 1 1/3 is, I'll put 1 1/3. 1 1/3. To get x by itself, we're going to subtract 2/3. Right, subtract 2/3 from both sides of the inequality. They cancel. That's going to become 0. So we're left with negative 1/3 x is less than or equal to, well, what's 1 1/3 take away 2/3? Well, that's going to be positive 2/3. Next step, divide both sides by negative 1/3. Divide by negative 1/3. They cancel. So we have x has to be greater than or equal to, have to reverse that inequality symbol because we just divided by a negative. And what's negative 2, or what is 2/3 divided by negative 1/3? Well, that's going to be the same as 2 over 3 times 3 over 1. 2 times 3 is 6. 3 over 1 is 3. So it's going to be 6 over 3, but it's negative. So we get x has to be greater than or equal to negative 2. Once again, I want to check it. Oh, well, let's graph it. So if I graph it, I'm going to have 0. Negative 2 is to the left of 0. It's closed. And my arrow is going to go to the left, or right. Now, 0 is in my solution set, so I'm going to try 0. 2, take away 0 is 2. 1/3 times 2 is 2/3. Is 2/3 less than or equal to 1 1/3? The answer is yes. All right. A few more. All right, let's try some of the other ones. Distribute. 1/6 times a is 1/6 a minus 1/6 times 1 is 1/6 greater than 2 times a is 2a. 2 times 1 is 2. Here we have variables on both sides of the inequality. I want to remove the variable with the smaller coefficient, so I'm going to subtract 1/6 a, subtract 1/6 a on both sides of the inequality. Right? They cancel. That's 0. So now I'm left with negative 1 over 6 is going to be greater than, well, what's 2 take away 1/6? Well, that's going to be 1 5/6 a minus 2. All right. Well, I'm running out of room, so let me give myself a little bit more room. So I'm going to go to my pen here. I'm going to erase that. All right, and then I'm going to continue the problem. So when I continue it, to get a by itself, we'd have to add 2, right, to both sides. Right, over here they cancel. What's negative 1/6 plus 2? Well, that's going to be 1 5/6 is greater than 1 5/6 a. Well, to get a by itself, we have to divide both sides by 1 5/6. Right, 1 5/6 here. Divide by 1 5/6 here. When we have the same thing in both the numerator and denominator, we get 1 has to be greater than a. Let's go to graph it. Right, 1 has to be greater than a. So that's going to be 0. 1 is to the right. It's an open circle, but because we have a reverse inequality, solutions are going to the left. 0 is part of my solution set, so let me check it because there was a lot of work there. So let's try 0. 0, take away 1 is negative 1. 1/6 times negative 1, that's negative 1/6 on the left. Negative 1/6 has to be greater than, let's see, 0 take away 1 is negative 1. 2 times negative 1 is negative 2. So is negative 1/6 greater than negative 2? The answer to that is yes. So I feel pretty comfortable about my solution set. Alright, let's try a couple more. I'm going to run out of room and I want to redo the one that we skipped, but let's see if I can squeeze this in here. Try to make it small. Distribute, distribute. So that's going to be 7 times 2. That's 14a. 7 times 3 is 21. Less than or equal to 5. Negative 2 times 3a. Negative 6a. Negative times negative is positive. 2 times 1 is 2. Next step. Let's put my 5 and 2 together, but I'm going to first remove the variable with the smaller coefficient. So that's going to be to add 6a. Add 6a. That's going to give me 20a minus 21 is less than or equal to positive 5, positive 2, that's 7. To get a by itself, we're going to add 21, add 21, right, that's 0. So now we're left with 20a is going to be less than or equal to 28. Divide by 20, divide by 20, so we have, they cancel, so we have a is less than or equal to 20 over 28, so that's going to be 1 and 8/20, 4/10, 2/5, so that's 1 and 2/5. 1 and 2/5 would be our answer. If we're graphing that on the number line, that's going to be 0. That's going to be 1 and 2/5 is to the right of 0. Close circle. Arrow's going to the left. Alright? And let's do this last one here. Alright, that should be plenty of examples. We have 8 plus 5 times z is 5z. 5 times negative 4, that's negative 20. Less than 2 times z is 2z. 2 times 7, 14. There's your first step. 2z smaller than 5z, so I'm going to subtract 2z from both sides of my inequality. Right, that's going to give me 8 plus 3z minus 20 is less than, right, that's 0. 14. Negative 20 plus 8, that's what, negative 12. So we have 3z minus 12 is less than 14. We're going to add 12 to both sides of that. When I add 12, right, that becomes 0. We're left with 3z is going to be less than 14 and 12 is 26. Divide by 3, divide by 3, and then z has to be less than 3 times 8 is 24, that's 8 and 2/3. Z has to be less than 8 and 2/3. If we're graphing that, right, here's 0, here's 8 and 2/3. To the right of 0, it's an open circle, arrow's going to the left. Now let's check this, right? So I need something that's less than 8 and 2/3. I don't know, something that's less than 8 and 2/3. Let's try 0, see if it works. Alright, actually let's try 4, because that's going to make it a little easier. I'm going to try 4. 4 is less than 8 and 2/3. 4 minus 4 is 0. 5 times 4 is, or 5 times 0 is 0. So I get 8 over here. 8 has to be less than 4 plus 7 is 11. 2 times 11 is 22. So is 8 less than 22? Yes, it is. So I feel pretty good about my solutions. Alright guys, just make sure you're checking these solutions, please. You should have a pretty good idea if you're right or wrong if you're checking the solutions. Alright, hope this has been helpful.